So this is where we left off on Wednesday, I think, where we went on ahead and we found the intervals for 68%, 95%, 99.7%, 1, 2, and 3 standard deviations from the mean, or for the sample mean in this case. And so if we only focus on the second interval, then we would say that we are approximately 95% confident that the average, or population average, that the population average IQ score is between our two numbers. I think it was 95.72 and 104.28. And if you weren't here on Wednesday, the intervals, we did them 1, 2, and 3 standard deviations. Here's 1, 2, 3 in terms of standard deviations for the sample mean. So there's that one. And I say approximately 95% because, spoiler alert, 2 does not quite equate with 95%. A z-score of 2.00 does not quite equate with the area of 95% between it and positive, between -2 and positive 2.00. So the next part is, what is the probability that the sample mean is exactly equal to the population mean? Well, probably 0. We had this discussion before that in calculus there's no area at one single point but area in a particular interval. So the chance for it to equal the population mean is probably 0. Alright, so let's see here. The 95% confidence interval we calculated is centered upon the sample mean. That's the center point. And it goes out about 2, I'll put 2 in quotes, standard deviations for the sample mean, which you guys know that by now is this guy, the standard deviation divided by the square root of the sample size. And then this guy corresponds to 95%, and I'll say approximately 95% of the area. Okay, so, well, I'll go back a slide. So, in the same kind of way that you probably saw this guy, we had 68%, we had 95%, and we had 99.7%. So, think about it in terms of course grades. If you had a chance to drop your lowest, or the grade that you don't like, or you like the least, you'd probably drop the 68%. So for our course, we're going to lean towards anything in the 90% plus range as far as confidence intervals are concerned. So we're going to work a lot with 1 or with 2 standard deviations, 3 standard deviations, like that. So 90% plus is what we're shooting for in this chapter. So you don't want any bad grades. You want grades in the 90s. Guess what? We want confidence levels in the 90s. And we'll focus on 90%, 95%, 99%, 68%, not so much. And a level C confidence interval has 2 components, okay? We talked about this before, where you have an estimate and a margin of error. So the issue is, I may not know what the true population mean mu is, but let me start with the sample mean. If I don't know the population mean, I'll start with the sample mean, but give myself a little bit of room in case I'm off. So that's the goal. The sample mean with a little bit of wiggle room can give me a pretty good idea of what the population mean is. And the confidence level, that's going to be the probability that our process over and over again will in fact capture the true population parameter. So common confidence levels again are 90%, 95%, pretty much anything in the 90s, maybe 80% is sometimes acceptable. And yes, we will get through chapter 14 today. We will start chapter 15 a little bit later on, and then you'll be able to finish up your last homework and quiz before spring break. Okay, so the confidence level is the success rate that our process will indeed work. And for a particular sample, it either is going to work or it's not going to work as far as capturing the true parameter mu. And it's about the process, not any one particular interval. Those are all just facts to be aware of. And here we go. Here's my disclaimer. Okay, we had this rule 68, 95, 99.7%. And you don't need to go a full 2 standard deviations. Spoiler alert. For 95% confidence, you only need to go 1.96 standard deviations. Do tell, Dr. Baker, you say. Well, let's find out why. So at the bottom of that page there, I gave you some values from the table A. So in table A, the area less than 2.00 is 0.9772. If you look up the area less than a negative 2.00 in table A, it's 0.0228. And if you were to subtract those two, you get 0.9544. So again, if you wanted the area between positive 2 and negative 2 in the z-chart, .9544 is the area in between those two. We've done that a few different times. So if technically 2 standard deviations is 95.44%, then we're going to shrink it down a little bit to find the area that's exactly 95%. .96 has an area below it of 0.9750. Now, if you're clever, you see where I'm going already, right? 97.5% is below, so it's 2.5% above, which also means that because it's symmetric, if there's 2.5% above 1.96, then there's 2.5% below negative 1.96. Or you can look it up in the chart. So from now on, when we talk about 95% confidence, we'll use a z-score of 1.96. In the old days with chapter 3, where you learn about the 68, 95%, 99.7% rule, we just use 2 as an approximate. 1.96 rounds to 2 with no problem there, okay? So that's not so bad. And these values are called so-called critical values as far as different values of z. For our confidence intervals. And here we go. So remember before we thought 95% corresponded to 2.00. It is actually 1.96 for the area between two z-scores. And a similar process gives you those other two characters, critical values, but I will not go through those explicitly. Just know the process still works. Okay, here's a question. And remember I said if your last name started a certain letter, I would call on you today? Remember that? Danger, danger, danger. Okay, let's see here. As the confidence level C increases, the width of the interval does what? Gets narrower, stays the same, gets wider. If your last name starts with a D, I'm talking to you. But are you talking to me? That's the question. Okay, so if your last name starts with a D, are you here first of all? Raise your hand. Okay. Your name again? Jed. Jed, that's right, Jed. Way to be bold. You could have easily just kind of hid. Right? So Jed, if the confidence level C increases, like 90% to 95 to 99, what do you think is going to happen to the width of the interval? Gets wider, right. Now again, Dr. Baker loves to make you guys squirm. Gets wider is correct. Jed, do you know why it might get wider? No. That's fine, Jed. You got the answer right? Look right here. 90% has 1.645, 95% 1.96, and 2.576. So if you have a formula like this, ZC for critical, we'll call this guy Z sub C. Then that expression behind the plus and minus symbol gets wider as we do a higher confidence level, 1.645, 1.96, etc. Also, you saw this back here. Go back in time. Back in time. Back in time. Back in time. There we go. So when we had 68%, it was narrower than the other two. We did 1 standard deviations, 2, and 3. So either of those rationale work, but Jed, right? He did a great job of just getting the answer correct, which is all I asked for. Okay, so yes, it does get wider.
Why are we more confident when it's wider? When we include more data, why does that make us more confident?
Okay, so we include. Okay, so we're including more data options, right? So how can I say it in layman's terms? It takes me 10 minutes to get to school, give or take 2 minutes. But if I widen the interval, 10 minutes, give or take 10 minutes, that has a lot more possibilities. So the chance of me being right it has increased a little bit. Okay. So the wider intervals incorporate more data values, and hence you have a better chance of guessing the true mean. Okay, so then here's how we arrived at this point. We start off in words, if you will. Okay, X bar is like the sample mean, give or take some margin of error. That's fine. And then for our example, we did 100, give or take 1, 2, or 3 standard deviations times the standard deviation of radical n. But in general, it looks like this guy. So that's pretty much the formula that you're going to see in chapter 14. And in fact, it's the formula you see on your notes, right? Right. They use a Z star. I use a Z sub C for critical value C. Same kind of concept. So then the confidence interval for mu is this guy here, the sample mean plus or minus some Z score times the standard deviation over square root of n. And then you have this process involved here. So for your purposes, we have an SPSC. We're going to state what we're trying to find. We're going to make a plan. We're going to solve it. And we're going to conclude what our findings have shown us. So state what in the world is the goal, right? That's kind of what are you trying to do there? Okay, plan. Maybe that's like the how. How are you going to go about that? Okay. And maybe like this is like the process. And then this guy down here is probably more so like an interpretation, if you will. It pretty much connects the process with the goal. Okay, we went through this procedure and our goal was achieved. And then we have a pretty healthy example coming up here in a second. So state, plan, solve, conclude, and again I post these over the weekend. Okay, so then practically what happens here, state and plan, thinking about what we want to do. We want to check to see if we can do it, then go ahead and do it, and then kind of explain and interpret our results in context. So here's our first big example. Adult IQ scores follow a normal distribution with a standard deviation of 15. You have a sample of 49 adults, and they have a sample average IQ score of 100. So I tend to like putting the given information somewhere nice and handy where I can see everything. And so then let's go ahead and go through the process. So give yourself a little bit of room. I think you guys have almost the rest of the page there. So if you state the problem, we want to know the average IQ score pretty much for all adults. So that's kind of what we're going to state there as the overarching goal. What is the plan? Let's go ahead and do a 95% confidence interval. So let's estimate the mean IQ score by calculating what we asked for 99% confidence interval. And I tend to dabble in shorthand. And I consider that to be a CI for confidence interval. So that's my state, that's my plan. Let's go ahead and solve it. So for the solve, we want to check a couple of things here. Our conditions. Well, do we have a simple, let's just make it even simpler. Do we have a random sample? And it says random sample is given. Yes, that's good. So I'll say yes. Okay, the next piece is it from a normal distribution? It says normal right there, yes. And then lastly, do we know the population standard deviation sigma? And we were given that as well. So and we worked with that for a while. So this is all kind of like the background to setting this problem up before we go any further. So I'm trying to write small, and I don't want to write any smaller. Next part, part B. This is the bread and butter of the exercise. This is the key step in the process. So in your homework, they may not ask you to state, plan, and solve part A, but they will expect you to work on this kind of part B step in the process. So the formula says this: the sample mean, give or take, some z-score, we'll call it the star, times the standard deviation over radical n. The sample mean is 100. We'll hold off on this guy. Standard deviation is 15 over square root of 49. All right, and then which number do we use for our z star here? Yes, ma'am? Yes. Yep. So which number do we use for our z star or zc? 2.576, right? Just from that previous couple of slides, I think it was. And again, that course, so what I'm going to do is right over here, 99% implies a z equal to 2.576. There you go. There we go, 2.576. So now we just go ahead and plug it into our calculators. .52 94.58 to 105.52. So I'm going to let that sit, stay on the screen for a few minutes, few seconds, while you guys kind of digest at least the step in purple, if not the other items in red, and definitely the number in green. Okay, just kind of let that all kind of sink in a little bit there. And then we'll do the conclusion on the next slide. How? You could use the inverse norm to find the 2.576. Not required in this class, but what I will show you from the calculator is actually even better than that. Okay? And that's a little hint that you'll need this today, right? Right. Okay, so let's go on. Let's see here. Go back to, maybe do it in red. So the conclusion, We are 99% confident that the mean IQ score for all adults is between 94.48 and 105.52. And let's have a sidebar, if you will. When we did 2 standard deviations before, and we did 3 standard deviations before, the intervals were, let me go back and find them, 95.72 up to 104.28. And then for 3 standard deviations, it was 93.58 up to 106.42. And so, remember, 2 standard deviations was approximately 95%, and this one was about like 99.7%, according to that rule. So it kind of makes sense that 94.48 is in between here for the lower bound, and then 105.52 is in between these two for the upper bound. So that seems plausible. So we'll call this sidebar A. Sidebar B, your textbook asks for margins of error sometimes. Margins of error are the numbers behind the plus minus, the 5.52. So sidebar B is that the margin of error is 5.52, just by going behind the plus and minus. Or another way of getting the margin of error is take the upper bound, 105.52, subtract the mean, 100. Okay, just a few notes there. So the upper bound minus the mean gives you the margin of error. 105.52 minus 100 is 5.52. A few ways of figuring it out. Also, the upper bound minus the lower bound divided by 2 is the margin of error, if you wanted to impress your friends this weekend. Enough sidebars, right? Right. Okay, let's see here. What is the probability that the interval computed above captures the population mean for all adults? Okay, so let's see here. So the process will give us a good 0. I'm sorry, the process gives us 95% for the process, but any particular interval is just either it does or it doesn't. So the process 95%. But a particular interval is either going to capture the mean or it will not. Okay, here we go. Law of large numbers. And we talked about this one already. The fun part. So as the confidence level C increases, the width of the interval increases also. We talked about that. Thank you very much, Jed. And then here's the fun part, the TIA 384 calculator. The function that we're focusing on is Z interval. Okay, so please take out your calculators. It'll come in handy for you. And on a midterm or a final, you would just need to write down Z interval and then whatever output you get from the calculator. You don't need to write down stat, test, Z interval, you do not need to list the keystrokes. All right, so moving forward, and then that's how you do it in jump. So let's now use technology to compute 95% and 99% confidence intervals for the average adult IQ score. So I think anyone else whose last name starts with D here? I don't think so. What about E? Move to L. E and F? Do I need to get my list out? All right. Last names of G and H. Raise your hand. Last name G. Last name H. Your name again? Ah, yes, Mackenzie. We'll call you Mac. All right. Anyone else last name H? Oh, Jacob? Nah, Jacob, I call you too much. All right, last name J. K? This is bad. Jacob, guess what? I need you. All right. Team Jacob, right? Remember that? Okay. So, Team Jacob is going to do a 95% confidence interval. Team Mackenzie will do the 99% confidence interval. Okay, and you have the steps on your notes there on how to go about it. So go ahead and give it a shot. And remember, you have this information, both of you. Sample size of 49. Sigma is 15. I think the sea level over here is 95%. This guy, the sea level is 99%. And you can use 0.99 or 99, right, as a decimal or as an integer is fine. You need something else, don't you? Oh, the sample menu. 100. So Team Jacob would be anyone, let's say, from the middle of the room down. Go right here. So Team Jacob is 95% down. Team McKinney, right here. 95% down. 1, 2, 3, 4, 5. Right through here. And then Team McKenzie, everybody back from McKenzie back. Okay? You guys got 99%. Jake's got 95%. Okay, Jacob, what'd you get? Okay. But it's a team, Jacob, right? So who else has it? Okay, is it Kayla?
Yeah.
All right, Kayla. What'd you get?
95.8 to 104.2.
95.8 to 104.2. Okay, so just follow those steps. Stat, tests, Z interval, then just type it in. Okay. Yes, ma'am? Okay, so let's see here. So you're over here on this data one. That's if I gave you like actual numbers like 5, 10, 17, 22. Go over to the stats guy. I'll get up there. There. Go over to stats, hit enter, and then now you can go ahead and go down and put in the rest of the information. Alright? How's it going? I don't see anything. Oh, there it is. Okay, good. Yeah, hit calculate. Got it? No, hit. Okay, so I am willing to help you troubleshoot. That's the name of the game. Give it a shot now. Just go all the way through and hit calculate. No! Okay, now do it. Yes. Yes. Got it. All right.
The answer is 5.
No. The answer is not 5. Do it again. Stop.
Okay.
There's the answer.
Oh, good.
Underneath the interval. So no need to go to the home screen after that. Okay. So 95.8 to 104.2. Looks good to me. Team McKenzie. Ray McKenzie?
Yeah, I have a low bound of 94.48 and upper bound of 105 approximately.
Huh. Are you sure?
I want to say yes.
Have we seen this before, McKenzie? 94.48, 105.52. All this writing. And Dr. Baker put you through all this writing just to use this thing and get it on one line? I think you do. All right? So again, it's just a way to kind of confirm what we did by hand. You can do it with the calculator. You would not lose points. You would just write like Z interval, and then you write that interval. Next problem. Full credit. Okay, if you have data entry issues, let me know, because we'll have another shot at it right here. Let's see here. As the confidence level C increases, the width of the interval gets wider. We talked about that before. 90% to 95%. Look here. 95% was 95.8 to 104.2. We go out to 99. Looks a little bit wider. 94.48 to 105.52. What about this one? As the sample size increases, the width of the interval does what? Gets narrower. Now you know Dr. Baker loves to press you guys. So why does it get narrower?
I kind of thought because there's more chances for outliers.
Okay, those darn outliers, we don't like them. Give me a mathematical reason. So she's got the right idea, yes?
Take
The square root of something. The square root of, not m, but n. Yes, that's correct. Both of you are right. Okay? So you have this formula, x bar plus or minus z standard deviation square root of n. You guys know from pre-calculus that as this guy goes to positive infinity, this whole thing is smaller, right? And you have a smaller margin of error, you become more precise. Gets narrower. Go backwards. Okay, so let's see here. Now, here's the best part about the calculator. We do not need to go through this step over and over and over again manually. We can just do it this way. We'll do the 99% confidence interval. Okay, we have a standard deviation of 15. We have a sample average of 100. And this time, we'll try a sample size of 49 and a sample size of 225. And you can use the calculator, that's totally legal. So 49, I think, is this guy. We did that before, right? That was this guy. 94.48, 105.52. That's no sweat there. Now for 225, all you have to do in the calculator is just change the sample size. I get 97. Yep. Let me put it in a different color, make it stand out a little bit. 97.424 up to 0.58-ish. 576 probably, but well, 558. Okay, and so let's see here, right? So the margin of error here is our usual 5.52. Now the margin of error is 2.58. Now I'm not going to discriminate here, right? So if you don't have the calculator, you can still go ahead and do it this way. That's no problem. $100 plus or minus what, 99? No, 2.576 times 15 over square root of 15. It'll give you the same answer. Okay. So yes, when you both of you guys are right. If you increase the sample size, the whole thing gets narrower. You become more precise in your estimates, and the interval is smaller. So again, Dr. Baker loves to ask you questions at the very end. We have a couple minutes, and I say for you to write down 3 concepts. You cannot leave without writing down 3 concepts that helped you in your knowledge of chapters 11 or 14. It could be about koalas. It could be about standard deviation over square root of n. It could be about the calculator. Z-scores. I'm open, but you cannot leave until I have 3 concepts, I guess you could say, that impacted your knowledge of chapters 11 and 14. So we will not get to 15. I'm not bummed about that, but that's okay. We'll start for 15 before 8 o'clock on Tuesday. But give me 3 concepts. Give me 1 concept, please. You can't leave till you give me 3. Yes, sir. What's that? Okay. The Z interval on a calculator is your new friend. All right. 2 more concepts. Yes, sir.
State plan solving.
Oh, okay, good. Kind of like having some order to your math, right? State, plan, solve, conclude. Very important stuff. 1 more. Yes, ma'am. Okay, good. So let's say a confidence level will be like 95%, 99%, etc. And then the critical value will be like 1.96, 2.576, etc., etc., etc. Okay, that's good enough. See you on Tuesday.